When we see an object, the light coming from the object passes through eye lens. Our eye lens refracts the light and forms image on retina. The image formed on the retina is inverted and it is real image. Then the retina converts image into signals and sent to the brain through optic nerve. Our brain can interpret those signals and identifies the color, shape and distance of the object from the eye. Here retina converts light energy, that is electromagnetic energy, into electrochemical energy and send it to the brain in the form of electrical pulses. The distance between retina and eye lens is 25 millimeters or 2.5 centimeter. As the image forms on retina, image distance is 2.5 centimeter. Here, when we look at a distant object, image forms on retina, and we look at close object, image forms on retina. How this is possible? That means image distance is same in both the cases, because as we know, if the object distance changes for a convex lens, then image distance also changes. Already we learnt in our previous classes. But here object distance is changing, but the image distance is fixed. It is always going to form on retina. This is possible only by changing the focal length of the eye lens. This is done by ciliary muscle. Ciliary muscle attached to the eye lens is relaxed when we see distant object by increasing the focal length of the lens. But when we see the near objects, focal length of the eye lens decreases by stretching the ciliary muscle. This is why we get pain when we see closer objects for longer time, as the ciliary muscle is stretched. This ability of eye to adjust its focal length is called power of accommodation. Here eye lens is increasing its focal length and decreasing its focal length. This ability we are calling as power of accommodation of our eye. For a young person, the power of accommodation is about 4 diopters. Let us discuss 2 important things here. One is near point, second one is far point. Near point, it is the near distance up to which our eye can see the objects clearly. For a healthy person, it is about 25 centimeters. This already we discussed as least distance of distinct vision. Yes. Coming to far point, it is the far distance up to which our eye can see the objects clearly. For a healthy person, it is infinite distance. So we can see the objects from 25 centimeters to infinite distance. That is the range of the objects we can see. What is the maximum focal length of our eye lens? Our eye lens has maximum focal length when we see far objects, that is, the object at infinite distance. In this case, object distance is equal to infinite, image distance is equal to 2.5 centimeter as image forms on retina. We need to calculate focal length. By applying sign convention, object distance is negative, that is minus infinite, image distance is positive plus 2.5. So the formula is 1 by f equal to 1 by v minus 1 by u. On substituting and simplifying, you will be getting f value as 2.5 centimeter. So the maximum focal length of our eye lens is 2.5 centimeter. Similarly, what is the minimum focal length of eye lens? Our eye has minimum focal length when we see the near objects. That is, object distance is equal to 25 centimeter. Then image distance will be, as usual, it is 2.5 centimeter as the image is going to form on retina. Applying sign convention, u is minus 25 centimeter, v is equal to plus 2.5 centimeter. Then the formula 1 by f equal to 1 by v minus 1 by u. If you substitute and simplify the values, you are going to get the minimum focal length of our eye lens is 2.27 centimeter. For a healthy person, the focal length of our eye changes from 2.5 centimeter to 2.27 centimeter. This ability of our eye we learnt as power of accommodation. When we see far objects, focal length of eye increases and focal length of eye decreases when we see near objects. Do you notice any difference in these two images? Yes, exactly. It is the size of the pupil. You might have experienced that you are unable to see clearly for some time when you enter from bright sunlight into a room with dim light. Did you? Yes. After some time, however, you may be able to see the things which are in the dim room. This is the function of iris. In dim light, the size of the pupil increases with the help of iris to allow more light to enter in the eye. In bright light, the pupil contracts with the help of iris to allow less light to enter into the eye to see the objects. Students will confuse what is the function of iris and what is the function of ciliary muscle. See clearly, iris controls the size of the pupil and here ciliary muscle is controlling the size of the eye lens. Remember these two things. Retina. It is the screen on which the image is formed by the eye lens. Retina contains a large number of nerve fibers and blood vessels and act as a light sensitive screen to receive the images. The retina contains more than 125 million receptors. Receptor is nothing but an organ or cell able to respond to light, heat or other external stimulus and transmit a signal to a sensory nerve. When stimulated by light, these receptors send impulses via the optic nerve to the brain, where an image is perceived. Rods provide vision during dim light or night, whereas cones provide vision during daytime or at bright. We see objects in dim light, but we cannot identify its color because at the time the cones are absent. Rods do not support the color vision, but cones are capable of color vision. The number of rods are about 120 million and cones are 5 millions. Blind spot. It is the small circular area at the back of the retina where the optic nerve enters the eyeball and which is lack of rods and cones and is not sensitive to light. So this area we are calling as blind spot. At this area, no rods and cones are present. So we cannot see the image formed at this spot. So how one can identify his own blind spot? Here is a small experiment to identify your own blind spot. Look at the image with the plus sign and the circle. Look straight at the image with your nose positioned somewhere between the plus and the circle. Close your left eye with your left hand and focus your eyes on the plus sign with your right eye. Do not look deliberately at the circle. Now move closer to the image slowly. Don't take your focus off the plus sign while you are doing this. At some point between 10 to 14 inches, the circle will disappear from your peripheral vision and the brain will read the surrounding white color to fill up the empty space. This exact spot is your blind spot. See how the magic happened. When we talk of blind spots, we always think of driving with an area of the road not visible through the rear view or side view mirrors. While driving on the highway, we need to make sure no one is in your blind spot before changing lanes. In this image, the yellow region is our blind spot.